Hello, everybody. My name is Larry Clark. I'm a long-time dental materials geek. I love dental materials and I love anything that makes them better. I'm privileged today to be with my great friend, Dr. Joshua Friedman. He is the owner and operator of AdDent Corporation here in the United States. He is also the founder of Dematron Corporation and was a research scientist at NYU. He has 2 degrees, one in electrical engineering, and also he's a dentist. We can trust him. Josh, we're so glad to be with you today.
Thank you for that kind introduction, Larry. It's a pleasure to be talking to you from Colorado, and I hope things are nice in Ruth Bay as well. I'm excited to be here to talk about the advantages of preheated composite, and look forward to answering any questions when we're finished.
Great. Well, let's get on with it. Josh, I'm going to run through all the items that we're going to cover today, and let's get with it. Well, everybody, we're going to cover a lot of things that are very important for all of us to know. We're going to cover today the reasons why we warm composites and what you can expect as results. And then there's going to be a great time for questions. And we're going to try and actually answer some of these questions in advance. We're going to talk about the obvious increased flow of the composites that warming brings. We're going to talk about higher conversion rates of the monomer, or sometimes what's called the cure. We're going to talk about decreasing the time of the cure, time savings. We're going to talk about less micro leakage, the #1 reason for restorative materials failure. We're going to talk about the increase of depth of cure with your curing lights. We're going to talk about reducing shrinkage stress, and all of the things that are happening from a chemistry standpoint when you're polymerizing your composites. One of the questions we get often is about, does it hurt to reheat our composites that we're using? Is there effect on the pulp? And what are all the clinical applications I can use my warming devices for? And of course, we like to talk about the future, and we're going to show you some things that are coming for the future. So Josh, we're going to start with the first area, and that'll be increased flow of composites.
So here's a study by Dr. Fred Rugerberg, which looked at the flowability of different materials at varying temperatures. The 2 temperatures were room temperature and also 140 and 130 degrees F. And what they found was that some of the materials had greater flow than others. For example, aesthetics had a 68% greater flow, while the Surefill had a 7% flow. So, but we see that all of them had a greater flow with heat, but some more than others. So the way they do this test is they take a glass slab that's heated and they press it on a sample of the material, and the composite extrudes along the edge and it forms a circle, and they can measure the circle. Since they know the volume of the material, they can calculate the thickness. And that's what we got. And I remember at a meeting years back, dentist I was talking to, I said, do you have a problem dispensing your material? He says, no, I don't have a problem. I let my assistant do it. Well, if you've ever tried to dispense some of these very thick viscous materials, you'll know that that is a problem for many dentists. Here's another study that looked at flow from a different point of view. If you've experienced dispensing heavy body composites in a syringe, you know how difficult that sometimes can be. I remember asking a dentist if it was difficult, and he says, no, I don't have a problem with it. I just give it to my assistant. Well, of course, the assistant would have a problem if that were the case. In any event, this was done by Dr. Broom at the University of Alabama. He looked at the effect of force required to extrude material at different temperatures. And of course, he found similar results to Fred Rugerberg, that when the material is warm, it's much easier to dispense. And that's what we're seeing in this graph. The force goes down as the temperature goes up.
So Josh, just listening to you, I'm kind of wondering if some dentists might be thinking that, with a warming device like the Calset, they would be able to decrease the use of a flowable composite. So would this take the place in many cases of a flowable composite?
Well, that's absolutely true, Larry. We'll see this in another slide, but basically what happens is when you use a flowable, yes, it does adapt better to the walls of the restoration and preparation. But what you also know is that flowables shrink much more than composites do. So what you're trying to do by creating a better adaptation, you're losing once you polymerize the material, because the material is going to shrink and you don't have that condition when you use warm composite. And we'll see this in the next slide.
I appreciate that, Josh. Let's go there now.
So here we're looking at a study by Wagner and others where they wanted to find out more about micro leakage. And what they did was they took 3 different extracted teeth, and these were 3 different conditions in extracted teeth. So the first condition was they put in a flowable liner and cured it in layers, 2-millimeter layers, and that's condition number 1. Second condition was they used no flowable liner, cured it in layers, and that's condition number 2. Condition number 3 was when they used a warm composite with no flowable liners. Now, what they do in a dye study is they soak the material overnight in a red dye, and then they section the teeth and they look to see where the red is penetrating into the restoration. And what they found was pretty obvious, that the condition number 3, which used the preheated composite, had the least amount of leakage. Now, why is that? Well, as we said before, when you use a flow, you're using it to get adaptation, but what we know about flowables is that they're less heavily filled and they're going to shrink more. In the case of a composite, it doesn't turn it completely into a flowable, but it becomes much more flowable-like. And at the same time, it doesn't certainly shrink as much as a flowable. So that gives us the best possible use of the composite, and also eliminates another product that you have to keep in the office.
That sounds good, Josh. Thanks.
This was a study by Dr. Stansberry at the University of Colorado. They used something called FTIR, as a big name, Fourier transform spectroscopy. And they do that because it shows them the exact amount of conversion. They look at a computer screen and they see a curve that actually shows how much the material has been polymerized. So by using that technique and heating the materials, they found that both of these 2 advantages take place. A, you're curing deeper at that same high level of conversion, and you do it with increased temperature. So bottom line, increasing temperature increases conversion, and it increases depth of cure. And that's what we're seeing in this curve.
So any dentist that is concerned about depth of cure with his polymerization light, regardless of what type, this is an advantage. Warming is an advantage to them.
Yeah, absolutely. And as we'll see in another slide, it's not just a question of increasing the power. That doesn't always give you the best result, and we'll talk about that some more. So
okay.
Again, there are other advantages of preheating, which we'll discuss.
Thanks, Josh.
One way to get the depth of cure is to measure the amount of hardness at different depths. So in the right-hand corner, we see a sample that's 6 millimeters in depth. And what they do with this is they cure from the top, but then they measure the hardness at these different levels, 1.5, 2.5, et cetera, down to 5.5 millimeters. You know that the composites are going to be hard at the surface. It's easy to test, but you don't really know what's happening at the bottom, and that's the critical part. So by doing this kind of a test, they split this sample in half, and they can take hardness measurements of the sample at different they found was that they had much higher bottom hardness when it was cured with the heated composite. And they did that both with an LED light and they did it with a halogen light. So again, from another point of view, if you're looking at hardness, that certainly correlates with the mono conversion or the curing. And it's nice to know that your material is fully hardened. It's pretty obvious that a harder material is going to be stronger. It's not going to fracture as easily. It's not going to allow materials to leach because it's not going to wear as much. So all those things together gives us better performance and, of course, reduced sensitivity for the patient.
Awesome. Thank you, Josh.
The depth of cure was done by the researchers at the IVAR, and they looked at something called refractive index. They found that the refractive index of the composite material increases as the material is heated, and that's what this data is showing here. And that, in effect, also causes the increased depth of cure. So if the light can get down into the material because the refractive index is higher, that's just another way of confirming that we're getting greater depth of cure.
Yeah, and it also is a real complement to the aesthetics of the overall aesthetics of the material too, because the increased monomer conversion is allowing more light to penetrate into the material, so it gives it more depth. Would you agree with that?
Yeah, and it gives it a more optically clear material, a more lifelike material. And I think most people realize that when materials are cured, they do lighten a little bit. If you've ever experienced that, you'll know it. And that's all part of this polymerization process. The thing we haven't talked about is color stability, but that's also part and parcel of greater polymerization. The material is stronger. It's not going to degrade. It's not going to change in shade as much as something that wasn't cured as well.
Wonderful.
So there are a number of research that have looked at the effect of preheated material, and this was done by Dr. Krejci at the University of Geneva. And again, he found what other people have also found, that when you heat the material, you get greater bottom hardness, and with all the advantages that we've talked about. This was an interesting study by Dr. Stansberry at the University of Colorado. They took 3 different curing lights, a weak light, this was early on, this was a weak LED light, a medium powered halogen light, and a very high powered plasma arc light. They looked at 3 different classes of materials, a microfill, a hybrid, and a packable. So at room temperature, which is shown in blue, 23 degrees C, we see what we would normally expect, that with a weak light, it would take longer to cure. In this case, it's 120 seconds. And these cures are based on that FTIR technique that I talked about earlier. So it's cured to a probably greater degree than most clinical materials are cured. And the same thing with the halogen, and that took about 90 seconds. And of course, the plasma arc light, as you can see, had the shortest cure time, around 20 seconds. But that's the room temperature. And the other materials followed in a similar way. They all cured at shorter times with the more powerful light, or saying it the other way, they took longer to cure with the weaker light. But interestingly enough, look what happens when we heat the material. This material was heated to 54 degrees C. They all cured approximately the same. They cured about 15 seconds on average. Well, what is that telling us? That's telling us that it's more important to heat the material than it is to use a weak or strong light. If you're worried about the intensity of your light, and they vary all over. There was a study years back where we looked at lights throughout a large population in Texas, and they found a huge difference between one office to another. And we see that even in universities. A close friend of mine who teaches at another university went around, tested the lights at the clinic and found differences. So the point is that instead of just trying to have the most powerful light, you should really be thinking about warming the material, and that will have other advantages as you'll see later, but eliminate the need for worrying about your light and know that you're getting a properly converted composite.
This is a marketing person's dream come true to say you can cure faster. And I just love where this conversation is going.
This was a study by Braga and Rugerberg on the effect of stress and temperature and the degree of monomer conversion. They took two different conditions. One sample was cured at 20 seconds at room temperature. You see that on the right. And another sample was cured for 5 seconds, but it was warm. You see that on the left. So what we noticed is that the warm material had a 53.7% conversion, and the material that wasn't warm had a 45.4% conversion. So in curing less time, we actually got more polymerization. That's really interesting, and it's important. Well, you might say, well, if I just cure longer, I can get higher conversion, and that's true. But something else is happening, as we'll see in the next slide. What's happened in the material that was cured at room temperature, that has a pretty high stress level, as you can see in the blue. The material that was heated in the red had much lower stress. So in effect, curing for 5 seconds was lower stress, and it gave us higher monomer conversion. So that's a combination that's almost too good to be true, but it is. And this is where that research is so important. So what is actually taking place when materials cure? Materials don't cure all at one time. They cure in stages. The first stage of curing, up until a certain point, is where a lot of these effects of stress take place. That point is called the vitrification point. And whatever conversion takes place prior to vitrification is the more critical one. So if we can do something to the material prior to vitrification, we can lower the stress in that material. And that something happens in heating. So when we heat the material, the molecules have a chance to relax, flex about one another, and form bonds that are more relaxed, in which case that's what's happening. We're getting lower stress in that kind of situation.
What's interesting about this diagram, Josh, is it sort of singles out everything we're talking about. This is a slide that's a courtesy of 3MSP, but it talks about everything: micro leakage, secondary caries, enamel micro cracks, post-operative sensitivity, adaptation, marginal staining. It's just...
Well, yeah, I mean, that's all true, but I want to just explain how some of that comes about. When you have bonding agents that bond to enamel or to den, whatever, and the material shrinks, it's pulling those structures with it. And so those structures can be deformed. And when tooth structure is under stress, you can just imagine what might happen when you bite down on one of those cusps. That's where cuspal fractures take place.
You're right. Let's get to the next slide, because I think there's more interesting things to appear.
So some people have asked the question, what effect would heated composite have on the dental pulp? And again, this was studied and looked at in detail. The picture to the left shows the thermocouples placed at different locations on the tooth. And what they found was essentially no significant increase, a very minor increase. And so where they found the greatest increase was with the heat generated by the curing light that polymerizes the material. And even if you have an LED light, and maybe you haven't thought about it, but if LED lights do also put out a lot of heat. And if you doubt that, you could just try putting it on your fingernail for 5 or 10 seconds, and see how it feels.
Thanks, Josh. Josh, one of the most common questions I'm asked is, how many times can you reheat the composite, and does something happen to the composite over time with repeated heating?
Well, that's a good question, and it was answered by a study by Dr. Rugerberg and others. Basically, they took material and repeated heating and cooling for 10 times. And then when they found that after 10 times, the amount of conversion they get is identical to what they did before the 10 times of heating and cooling, they realized the fact that there isn't any damage to the material. Just parenthetically, we make a heating device designed for syringes, and that so that it only heats up the front about 20% of the syringe. So you're not really even heating the whole contents of the syringe, you're just heating the front. But even so, you're not going to damage anything by using that syringe over and over again.
Wow, you really thought that through. I really appreciate that, because I think most people assume the heaters are heating the entire syringe. Yeah,
not ours.
Yeah, very good. Thank you, Josh.
With the advent of bulk fill materials, people have asked the question, does this preheating effect also extend to bulk fill material as it does with normal composites? And the answer is it does. This was a study that looked at 5 different bulk fill composite materials. The RT refers to room temperature in this graph, and the pH refers to preheated. And what we see here in every single case, for every single material, anytime the material was preheated, the shrinkage force was less. And that even extended to sonic fill, which was designed to be vibrated. So I think it's pretty clear that whether you use a composite that's a normal composite or a bulk fill composite, you're still having advantages by preheating the material, as shown by this study.
Yeah, Josh, you mentioned sonic fill, and it uses vibratory mechanism to achieve flowing. Does it also have some of the other attributes of warming, like a higher degree of conversion, things like that?
No, that's a good point, Larry. Sonic fill was just designed to flow better into a cavity and hopefully adapt to the cavity walls, but it doesn't provide the advantages of heating, which also provides better flow, but provides greater depth of cure, greater monomer conversion, and as we see, less shrinkage and shrinkage stress.
And of course, with warming, you can warm anybody's composite. No one manufacturer is.
That's true. Yeah, that's true. And all materials will flow more readily and have these advantages in the preheating application.
All right. Thank you, Josh. Josh, in my history of dental materials, I've noticed that warming composites is, the applications have expanded. And, in the beginning, I just thought it was great for bulk filling and, flowability and all that sort of thing. And I've come to learn, from reading articles from Pascal Manier and Greg Helvey and others making videos now showing it for cementation and all kinds of stuff. Can you elaborate?
Yeah, well, nowadays people are using composites for cementation because heated composites offer several advantages. They're going to flow as well as or close to eluting cement, but they're not going to shrink. So if you have a margin that has a microscopic space, you'll have a fill-in. You won't have a place where cement can leach out. Years back, I spoke to a professor at the University of Zurich, where they use a lot of CEREC applications for inlays and onlays, and they exclusively cement with light cured cement. And they're doing that for the reasons I've just described. If, for example, you're going to do a porcelain veneer, One technique is to warm the veneer with the composite in it and then place that on the tooth, of course, after you've prepared it and done those procedures. And what you find is that the material will extrude around the margins of the restoration and cool rather quickly when it's outside of the restoration, making it much, much easier to remove with an explorer. So in effect, you're getting a better bond, a stronger bond, and you're reducing the time it takes to do veneer bonding procedures.
Yeah, I read several articles about that, and I was really impressed. In fact, recently I saw an article where they compared the warming of composite to that of the use of a dual cure cement, which most dentists use in the posterior. They'll use dual cure cements. And I was astonished to see that the film thickness was better, the color stability was always better.
Well, I think that was the article by Pascal Meunier that you're referring to. And I think they also found out in that article that the crowns that they were placing seated better with using this technique.
Yeah, that was really impressive when I saw that. I also know that veneering, cementing veneers has always been a challenge. So kind of what you're saying is the way to clean up the gingival margins could be much easier with warmed composites rather than flowables, for example. And again, back to flowables, I think many dentists are using flowables for veneers. And now back to the physical property aspect of shrinkage stress, and so on. Yeah,
you're absolutely right. I think once you try the technique, you'll realize that there's a lot shorter time it takes to do these cementations with composite.
Yeah. Well, thanks, Josh. Josh, a lot of people have shown much interest in the cementation aspect that we've been talking about using warmed composites. Dr. Troy Schmetting recently did a video showing how he integrated it into his practice, and he uses it every day for all cementation procedures that he does. I thought this would be a good time to show it. So here we go. Since you and I have become such good friends, you've developed something that I'm tremendously excited by. Can you tell us more about Compex, please?
Well, yes, thank you, Larry. We've worked on and we'll be introducing it in the fall, is a handheld recharge heated composite dispenser. And that will heat compules. It'll bring the temperature of the composite up to the desired level that we have, which is 68 degrees C. It'll bring it to the tooth and dispense it very close to that temperature. It'll be useful without recharge. It'll go for over 100 applications, and it'll be easy to load and reload, and it'll become as ubiquitous as a curing light, I believe, down the road, because more and more people are going to be using heated composite, and this would be an easy way to go. So I want to thank everybody for listening to this program. I know there's going to be a section of time for questions. I'll be happy to answer them. And I'll just turn the last slide over to Larry. Thank you, Larry.
Yeah, thank you, Josh. There's two dentists, researchers, lecturers that we both honor and respect, Dr. George Friedman and Dr. Ivo Krejci from Switzerland. And they did an article together, and their conclusion was that the era of curing composites under elevated thermal conditions, long accepted and practiced in the fabrication of extra-oral composite restorations, is now available for direct intraoral composite restorations. The early research confirmed by clinical practice indicates that this is a practical means of rapidly and easily improving composite properties in the dental restorations. I don't think anybody could have summarized everything we're saying today. Josh, what do you think?
Well, I think that's great. And they're both highly respected clinicians and researchers, and it's nice to see more of them getting on board. There's been studies, one that we have on our website. It went back actually 20 years and looked at the research on heated composite for a long period of time, and they found that you know, it's been around. It's just that I hate to say this, but I think composite manufacturers like to give the impression that you don't have to do anything to our material because the material is perfect the way it is. But that's not actually true. I mean, it's preheating has been around for way more than, it's probably closer to 40 years. And there's an article in 2020 by Lopez and colleagues that reviewed the published literature since 1980. And they concluded that preheating restorative materials is a simple, safe, and effective procedure. And it is. So I think we're looking at a future where, you know, heating composites and the means to do that are going to be very, very common, just like curing lights were, you know, 20, 30 years ago.
Yeah. Well, I know some major manufacturers are really focusing on warming composites now. And so it's there's sort of a revival coming, and I'm excited by that. Well, thank you, Josh. I too want to thank everybody that is viewing this, this educational piece that it's been a great honor to give. I want to let you know that not just this presentation, but other presentations and over 60 research articles are available at the AdDent website, which is listed at the bottom of the screen. And, you know, and Dr. Friedman's email address is kindly provided in case you have a question that, you know, you want to pose to him. And so we want to make sure that, you know, we're here for you. You know, Mahatma Gandhi, who's a hero of mine, said, there is more to life than simply increasing its speed. And so much about dentistry these days is about how fast we do everything. I was raised, it's how well we do everything. And so with that said, I want you to know we're on your side. We know, you know, it's about how well we do everything. I want to thank you for your attention today. We thank you that for your kindness in listening and watching. And we invite you to engage in warming of composites for the betterment of your patients. And we thank you for this time. Take care, everyone. Bye-bye.